Hello, welcome to Lab 1. I hope by now you have watched the introduction movie that I have sent you and have installed all the necessary components, programs and everything on your computer, and you are ready for the lab. Alright, the lab reports for the first 5 labs, what all you need to do is fill in the spaces that I have provided and send me back the same document that we have in the assessment drop box. Is that right? That will be for the first 5 labs. Now after that I will tell you how to write the lab reports. Okay, in lab 1 we will be looking at and practicing some of the basic concepts we will be using right through the course. The concepts of units, the concept of error in measurement, the concept of percentage error and percentage error and percentage difference. All these concepts we will be looking at. How to represent data graphically and how to get the information from a graph, and all these things we will be discussing and practicing today. What are some of the most commonly measured quantities? There are 3 quantities that are most commonly measured, and they are called the fundamental quantities. Length, mass and time are called fundamental quantities. And in order to measure, we have to make use of a unit. What is the unit of measurement? Well, the unit of measurement tells you the type of quantity measured. For example, the unit for measuring length is a meter. I have a meter stick here. Well, that is 1 meter. And to measure length, the unit of meter is used. What is the unit for measuring mass? Mass is measured in a unit called kilogram. I'm holding 1 kilogram in my hand. So length is measured in mass, length is measured in meters, and mass is measured in kilogram. The third fundamental quantity is time, that is measured in seconds. Well, is it possible for us to measure all lengths in meters? No, you need subdivisions. Very often we will be measuring small units. I have told you in the introduction, you must get hold of a ruler. Well, the ruler you will be getting hold of will be about that much in length, about 30 centimeters in length. That means a meter is divided into centimeters and millimeters. Now tell me, how many centimeters make a meter? Have you got any idea? Well, there are 100 centimeters in a meter. If you look 90 to 99, 100. And each centimeter is divided into 10 millimeters. So all these division that you need to be familiar with, and let's go through some of them. It's very important how you can convert from one form to the other. As I had told you earlier, you must keep a printed copy of the lab with you when you start a lab. Well, length is measured using a meter ruler I just showed you, and the unit of length is the meter, and we use lowercase m to represent a meter. Mass is measured in kilogram, and look at the way we write kilogram, and the time in seconds. And a meter is divided into centimeters, millimeters, micrometer, I want you to be familiar with these units. Nanometer, picometer. A picometer is 10 to the power of negative 12 meter. I have given all these over here, and have a look at this. Now, you must express all these using powers of 10. 10 to the power of 2 centimeter is 1 meter. That means 1 centimeter is 10 to the power of negative 2 meter. 10 to the power of 12 picometer is a meter. That means 1 picometer is 10 to the power of negative 12 of a meter. 1 trillionth of a meter is a picometer. 1 kilometer is 1,000 meter. All right, you know all these things. Let's move on. Now, what I would like you to do is, after looking through these, complete these tables. 1 kilogram is how many grams? Well, a kilo is 1,000. Is that right? A mega is a million. So a megameter is a million meter. Well, all those things you must be familiar with. Now, a milligram, what's a milli? A milli is 1,000th. A milligram is 1,000th of a meter. Therefore, 1 kilogram will contain how many milligrams? Well, I'm going to leave it for you to write that down. Therefore, 1 milligram is what part of a kilogram? We will also be measuring temperature very often in the lab, and we will be measuring temperature in degrees Celsius. And of course, you know that in the system of units that we use, called the MKS, the temperature is measured in Kelvin. And what's the relationship? Temperature in Kelvin is temperature in degrees Celsius plus 273. That means 273, 0 degrees Celsius is the same as 273 Kelvin. All right? And an important information, an interval of 1 degree Celsius is the same as an interval of 1 Kelvin. So when you talk about temperature intervals, the intervals measured in Celsius is the same as the intervals measured in Kelvin. All right? And now I want you to complete these tables. 1 millimeter is what part of a centimeter? I want you to give me the answers using powers of 10. For example, 1 millimeter is 10 to the power of negative 1 of a centimeter. Therefore, 1.2 millimeter is 1.2 times 10 to the power of negative 1 centimeter. All right, complete this table using the same principle. All right, there's no problem there. Now, what are fundamental units? I have told you the 3 most commonly used quantities are length, mass, and time, and these units are called fundamental units. All other units can be obtained by suitably combining the fundamental units, and therefore those units will be called derived units. That means the unit of area. What is the unit in which area is measured? Area is measured in square meter or square centimeter and so on. That is a derived unit. What is the unit of speed? Well, speed is meter per second. Meter per second. And look at the way we write it. Meter times second to the power of negative 1. These are the kind of representations I want you to be familiar with. When you want to write a unit meter per second, we will not write meter per second like this, but this will be the standard way to write meter per second. Okay. And you have a third set of conversions. Now tell me, how do you convert from meter squared to centimeter squared? Let's talk about that for a while. Well, you know that 1 meter contains 100 centimeter. Is that right? Let me write that down. So I have 1 meter is 100 centimeter. Tell me, if I have an area of 1 square meter, it means 1 meter long and 1 meter wide. Now, how many square centimeters will that be? 1 meter squared is 1 meter multiplied by 1 meter. That is what we call 1 meter squared, which is the same as 100 centimeter multiplied by 100 centimeter, right? And that will be a 10,000 centimeter squared. In other words, that will be 10 to the power of 4 centimeter squared. So 1 square meter contains 10,000 square centimeter. Tell me then, 1 meter cube, 1 cubic meter contains how many millimeter cube? Well, that will be 100 centimeter times 100 centimeter times 100 centimeter. Is that right? 1 meter cube is 1 meter multiplied by 1 meter multiplied by 1 meter, and that will be 10 to the power 6 cubic centimeter. So 1 cubic meter contains 1 million cubic centimeter. Now, you know that a cubic centimeter is also called a milliliter. A milliliter. So 10 to the power 6 centimeter cube is the same as 10 to the power 6 milliliter. What is a liter? I have a beaker here whose capacity is a liter. Now look at this beaker. It is 1000 milliliter. You can see it there. 1000 milliliter is the capacity of this. That means it will hold 1 liter. When you fill it up to here, it will be 1000 milliliter. And you can see a measuring cylinder. Tell me, what is the capacity of this? How many milliliters can this hold? Its capacity is 50 milliliter. And if you want to measure, what is the least amount you can measure with this? In other words, how much is 1 division here? If you look at this, this is 10 milliliter, and the next is 11, 12, 13, 14, 15. So each division is 1 milliliter, which is 1 centimeter cube. Is that right? Okay. Now tell me, if you have some centimeter cube, how do you convert that to meter cube? An important skill that you need right through this course. How do you convert centimeter cube to meter cube? If 1 meter cube contains 10 to the power 6 centimeter cube, then 1 centimeter cube will be equal to 10 to the power of -6 of a meter cube. So 1 centimeter cube is a millionth of a meter cube. Similarly, 1 centimeter squared equal to 10 to the power of -4 of a square meter. And these are important skills. Well, we need to convert 22 meter per second to kilometer per hour. Now, first of all, write it like this. This will be 22 meter divided by second. Alright, in the next step, it will be this meter has to become kilometer. A meter is what part of a kilometer? Well, a meter is 1,000th of a kilometer. So that will be 10 to the power of negative 3 kilometer. And a second now needs to become hour. Well, 1 hour contains 3,600 seconds. Therefore, 1 second is 1 over 3,600 of an hour. So you can see this 3,600 is therefore going to go up, and that will be 22 times 10 to the negative 3 times 3,600. Well, has now become kilometer per hour. Is that right? Yes. Now, actually there is a very easy way, quick way to convert meter per second to kilometer per hour. Let me show this to you. Look at this. 10 to the power of negative 3 means divide by 1,000. So if I cut this off, all you need to do is divide 3,600 by 1,000. So this is the same as 22 multiplied by 3.6 kilometer per hour. So in order to convert meter per second to kilometer per hour, what all you need to do is multiply the number by 3.6. Now, in that case, if I give you kilometer per hour, what is the quickest way to convert kilometer per hour to meter per second? It will then be divide by 3.6. So, kilometer per hour will become meter per second when you divide by 3.6. And meter per second will become kilometer per hour when you multiply it by 3.6. Okay, don't forget these simple skills. Okay, now I want you to use the same method to convert gram per centimeter cube to kilogram per meter cube. Alright? Okay, and now let's go and talk about dimensions. Every physical quantity has a dimension. In fact, the dimensions of all physical quantities can be described using the dimensions of the fundamental quantities: length, mass, and time. Well, the dimension of length will be expressed using uppercase L. And the dimension of mass is uppercase M. The dimension of T is uppercase T. So don't confuse these with the units. The dimension of length, we use uppercase L. The dimension of M is the uppercase M. The dimension of time is the uppercase T. In that case, the dimension of volume will be L cube, because a volume is obtained by multiplying length 3 times. So the dimension of volume is L cube. The dimension of area is L squared. Okay, what is the dimension of density? What is the dimension of density? Density is mass divided by volume. And therefore, you replace mass by its dimension. Will be uppercase M. Volume is L cube. And how do you therefore write the dimension of density? Now, watch how it is written. We write it like this. The dimension of mass is M, and the dimension of volume is L cube. Now, is this right to leave it like this? Not quite. You must write the dimensions like this. That will be M times L to the power of -3. That is how the dimension should be written. M times L to the power of -3. All right? There's nothing in here. M times L to the power of -3 is the dimension of density. Okay. Now, in the same way, what is the dimension of speed? Speed is distance divided by time. Distance is the length. And therefore, what is the dimension of distance? Is L. The dimension of time is uppercase T. So what is the dimension of speed? I want you to write it in the proper form. Okay? If the dimension of speed you know, tell me what is the dimension of change in speed? Is that difficult? I think many of you have a little difficulty understanding it. If we use the unit of money as dollars, what is the unit for change in the amount of money? That again will be dollars. In the same way, if the unit of speed is, have you obtained the unit, not the unit, dimension. Have you obtained the dimension of speed? Well, that will be LT to the power of -1. If LT to the power of -1 is the dimension of speed, what is the dimension in change in speed? It's the same thing. All right, in that case, what is the dimension of acceleration? I'm going to leave it for you to obtain the dimension of acceleration. Okay. You will soon see later on in our lessons that force is measured in a unit called Newton. And a Newton is a kilogram meter per second squared. I want you to write the dimensions of force. Well, kilogram is mass, the dimension is m, meter is length, the dimension is uppercase M. Now, please don't use lowercase letters for dimensions. It must be uppercase letters. And second is time. So, obviously, the dimension of force will be mLT to the power of -2. You can see I'm giving you all these answers. Well, it means I want you to practice all these. Let's now talk about error in measurement. You see, in the lab, whenever you do lab, you will be taking measurements. And whenever you take measurements, error is part of measurement. Tell me, what are some of the ways you can make mistakes in your measurements? Well, one of the common ways you can make an error in the measurement is the limitation imposed by a measuring instrument. You see? For example, let me show you how the limitation of a measuring instrument will cause an error. For example, if I want to use this meter rule to measure the length of this box, Can you measure the length of this box? What is the length of this box? I know you're going to measure it exactly 24 centimeter. But it's not really 24 centimeter. I'm going to measure it as 23.9 centimeter. But is that an accurate measure? You see, the smallest division on this meter ruler is 1 millimeter. That means that smallest division put a limit on the accuracy of my measurement. So what is the least accuracy I can actually get in this measurement? It is 1 millimeter. I cannot measure using this meter rule anything more than 1 millimeter or anything less than 1 millimeter. Is that right? So that is the accuracy of this meter ruler. In the same way, what is the accuracy of this measuring cylinder? Well, the accuracy of this measuring cylinder is 1 milliliter. I cannot measure anything less than a milliliter on this. So look at the way a measuring instrument is actually putting a restriction on the accuracy of your measurement. And in most of your measurement, this is going to be true. And therefore, there is always an error involved in measurement. Very often, I will be asking you to obtain the percent error in your calculation. Now, this is the definition of percent error. The actual value minus the measured value, the absolute value of it. In other words, I don't want a percent error that is negative. The percent error will be always positive. The actual value minus the measured value divided by the actual value multiplied by 1,000 will give you the percent error. That means the percent error can be calculated only if you know the actual value. If you don't know the actual value, then you cannot calculate an error. Can you? Well, you can only calculate the difference between a measured value and a value that is supposed to be. And therefore, let's also look at the meaning of percent difference. How do you calculate the percent difference between two values? And this is the definition. Absolute value of, again, percent difference is a positive quantity. Difference of two measured values. So if you are making two measurements, and if you want to calculate the percent difference between those two values, then find the difference between those two values, divide it by the average of those two values, and then multiply it by 100. That will be the percent difference. So take note of these equations and keep it with you all the time. I want you to use that concept to do these problems. I'm going to leave them for you to do them on your own. There are 4 or 5 calculations I want you to do. And remember, the report on this lab is you complete the space that is given. And you know how to do that. When you go to the assignment drop box and click on the file, this Word file will open. And you can come on and type in the space here. Alright? So complete all the spaces, then upload it and submit it to the assignment drop box so that I'll be able to grade that for you right there. Okay. Let's now go on and talk about significant figures. Well, I'm sure most of you are familiar with significant figures. Now, this is one way to specify the desired accuracy of a calculation. So, significant figures determine the accuracy of a calculation. And how do you determine? the number of significant figures in a calculation. How do you know a given number has how many significant figures? And most of you know this. For example, zeros at the beginning of a number are not significant. For example, 0.00257 has only 3 significant figures. What are they? This 2, 5 and 7. These zeros are not significant. Now, how about this? Zeros within a number are significant. 20.06 has 4 significant figures. All these are significant. And rule number 3, zeros at the end of a number after the decimal point are significant. For example, 502.00. Now, this number tells you that I am expecting an accuracy of 100th. Accuracy of 100th in this measurement. That is what it means. 502.00 has 5 significant figures. And look at the way we write it. 5.00 times 10 to the power of 2. How many significant figures are there for this number? There are 3 significant figures for that. 5.00 times 10 to the 2. And now, a common question very often students ask is, how many significant figures should my answer contain? What is the answer for that? And look at the answer. The final result of an operation should contain the same number of significant figures as the quantity with the least number of significant figures that was used in the operation. For example, a question here, the base of a triangle is 7.2 centimeter. How many significant figures are here? 2. The altitude is 4.35 centimeter. How many significant figures are there? 3. Now, find the area of this triangle. Tell me, how many significant figures will there be in the answer? The answer will contain the least number of significant figures that was used in the operation. That means the answer here will contain only 2 significant figures. All right. I'm going to leave that for you. Now, the last part of our discussion today is graphing. Well, every lab I expect you to draw a graph or a chart so as to interpret your measurements. And so, you must be familiar with the concept of graphing. And most of the graphing we do will be linear graph. Now, look at this. Y equal to 10t plus 12. What kind of a graph is that? I'm sure you are familiar with all these concepts. You know that a linear equation is of the form y equal to mx plus b, where m is the slope and b is the y-intercept. Well, y equal to 10x plus 12 has the slope 10 and the y-intercept 12. Is that right? So the graph will look like this, where the y-intercept, this will be 12, and what is the slope? The slope is, well, you need to know it very well. Delta y divided by delta x, the change in the y value divided by the change in the x value. Well, so every time we come across an equation, I will be asking you to write that equation in this form, y equal to mx plus b. But in most of the cases, B will be 0. That means the graph will be passing through the origin. Is that right? Now, if a graph passes through the origin, we say y equal to mx. Now, this means y is directly proportional to x. You see, when y is directly proportional to x, a graph of y against x will pass through the origin. Now, I use the term a graph of y against x. You see, a graph of y against x means y on the vertical axis and x on the horizontal axis. Tell me, how do you draw a graph of h against t? A graph of h against t means h on the vertical axis and t on the horizontal axis. That is the meaning of a graph of h against t. Okay, now suppose I have an equation f equal to 1 over 2l square root t over mu, and I ask you to write this equation in the y equal to mx form. Y equal to mx form. Now remember, in the equation y equal to mx, y is a variable, x is a variable, x is the independent variable, y is the dependent variable, and m is a constant. In every lab that you do, you should be able to say what are the variables. Well, the variables are the measurements that you take. You see, suppose I tell you L is a variable and T is a variable. L is a variable and T is a variable. F and mu are constants. How do I write this equation in the form y equal to mx? So, you know L is a variable and T is a variable. Now, the first thing you can do is square this equation so that the square root will go. So, it will become f squared equal to 1 over 4l squared times t over mu. Is that right? I squared it. And now, you know that L is a variable and T is a variable. Solve for one of the variables. Let's solve it for L squared. Can you solve this equation for L squared? I can say L squared equal to 1 over 4f squared times t over mu. So, you got L squared a variable and t is another variable. And so, look at the way I'm going to rewrite the equation. I have L squared equal to 1 over 4f squared mu, I put it all together, times t. And now, this is of the form y equal to mx. What is my y? Y is L squared. And what is x? X is t. And that means if you now draw a graph of L squared on the vertical axis and t on the x-axis, on the horizontal axis, that graph will be a straight line passing through the origin. And if you measure the slope of that graph, what will be the slope of that graph equal to? The slope will be equal to this quantity, 1 over 4f squared mu. That means you know the value of the slope. And if I give you the value of f in the experiment, you will then be able to calculate the value of mu. And this is the method we will be using in our experiment as we move on. Okay, well, I have a similar equation here. If f equal to 1 over 2L square root of t over m, where t is the independent variable, watch that, and f is the dependent variable with L and M constants. So this time you watch the variables. The t is the independent variable, f is the t is the independent variable and f is the dependent variable. Use that concept to write this equation in the form y equal to mx plus b. But of course b is 0. Alright? And then identify your m and b. I gave you the answer for b already. It is 0. Identify your m. What will be? Now, don't confuse between this m and this m. This m is different from the slope m. Alright? Okay, answer that for me and you will be alright there. Alright. Look at this now. The distance traveled by an object moving with a constant acceleration a is given by the relation x equal to 1/2 at squared. Write this equation in the form y equal to mx plus b, knowing that t is the independent variable and x is the dependent variable. Well, it is actually written in the y equal to mx plus b form. Tell me, what is b here? B is 0. Tell me, what is x here? If this equation is of the form y equal to mx, what is your x? Your x is t squared. Remember, many of you would say x is t. No, it is t squared. And your y is x. That means you must draw a graph of, what kind of graph will you draw in order to produce a straight line graph? You must draw a graph of, well, let's see what that graph will be. You must draw a graph of x on the vertical axis and t squared on the horizontal axis. You see that? Your y, in place of y you have x, so your x must be on the vertical axis and t squared is in place of x, so t squared on the horizontal axis. That graph will be a straight line like this. Now tell me, if you measure the slope of this graph, what will that slope represent? Well, the slope of that graph will be 1/2 a. 1/2 a is the constant there. So if you draw a graph of x on the vertical axis and t squared on the horizontal axis, we call it the graph of x against t squared. If you draw a graph of x against t squared, you get a straight line passing through the origin, and the slope of that graph will be 1/2 of a. Okay, in that case, I want you to do this exercise. And what is the exercise in here? Well, the exercise is, I have given you a situation where the values of x are given, the values of t are given. What are you supposed to do? Now, the following table lists the distance traveled against time of a car that starts from rest. Use this data to obtain a straight line graph. Alright, tell me, if you draw a graph of x on the vertical axis and time t on the horizontal axis, will you get a straight line graph? No, you will not. Why? Because x equal to 1/2 a t squared. So to produce a straight line graph, what will you do? First of all, you need to square the time values. And then your graph will be x on the vertical axis and the square of time on the horizontal axis. And then measure your slope, and that slope will be 1/2 of a. That means I can write it like this. Suppose I got the slope as, I'm going to give you a number. Suppose I measured the slope and I got the slope as 5.2. Now, that 5.2 will be equal to 1/2 of a, and therefore what is a equal to? A equal to 10.4 meter per second squared. So we use the slope to obtain the value of a, the acceleration. Okay. Now we will be practicing this many times as we go on with our lab. Alright. And now, to end this lab, I have given you an exercise. A very simple exercise. A room is 6.25 meter long, 4.06 meter wide. Find the area of the floor in meter squared, centimeter squared, and in kilometer squared. We have practiced all that. And if the ceiling of this room is 3.25 meter high, well, you know the area of the room. If you now multiply it with the height, you get the volume of the room. Express the volume of air in the room in meter cube, centimeter cube, and in kilometer cube. All right. Now, if the density of air is 1.29 kilogram per meter cube, what is the mass of the air in the room? If you know the volume of air and if you know the density, how do you obtain the mass? Mass is volume multiplied by density. Alright, obtain the mass in kilogram. That means you must use the volume in, what unit will you use? The density is kilogram per meter cube. That means the volume value you use must be in meter cube. So obtain the mass of the air in the room in kilogram. Now, if the molar mass of air is 29 grams, how many moles of air are there in the room? 1 mole of air has a mass of 29 grams. And you know the mass now in kilogram. Make that into grams, and if you divide by 29, you get the number of moles, right? Alright, and each mole, if you've done chemistry, which most of you have, I think, if each mole of air contains 6.02 times 10 to the 23 molecules, then how many air molecules are there in the room? Alright, you can do that on your own. And from that, calculate the mass of 1 air molecule. You see how simply you can calculate the mass of 1 air molecule. Well, I think we have got a very good lab in here. I want you to complete this lab. Now, fill in all the relevant steps. Don't just write the answers. I want all the relevant steps in the space that is required. And it is completed, upload it, and submit it, and make sure that the labs are submitted before the due date. All right? I will see you for lab 2 later on.